In this video, we're going to be finding limits at infinity. And the subtitle, if you notice, is going to be acronyms bubble, bow tie, and SOSCOP. So what's the objective for this video? We are to determine when a limit is a limit at infinity, how to identify it, evaluate limits at infinity, and finally distinguish between bubble, bow tie, and SOSCOP. Now, what is a limit at infinity? How do we know it's a limit at infinity? And the easiest thing, students love this one because it's very easy to identify. If you notice down here at the bottom, the x value here, the x value that we're approaching, it's infinity. So how do you identify it? If you see an infinity down here, it's going to be a bubble, bow tie, SOSCOP problem. All right. Now, please understand that limits at infinity is synonymous with horizontal asymptotes. Horizontal asymptotes. And some of you might ask, what do you mean by that? To find horizontal asymptotes, and you're going to be doing the identical same thing as limits at infinity. And for those of you that are visual, let me explain. All right. Here is a function, and a function is going up like this, and it's going to be approaching some imaginary asymptote. Okay, that means that it's approaching it but will never reach it, and this asymptote is located at L. So what we're gonna say that the limit as x approaches infinity of my function is gonna be L. That's a horizontal asymptote. And what do I mean by x goes to infinity? Well, this here is 1, this here is 10, this is 100, this is 1,000, and it goes on and on and on and on. So guess what? What happens when we get further and further to the right? Over here, we're going to find out that there's an infinity on the right. So x is approaching infinity. And if we were to go to the left, we would be approaching x approaches negative infinity. Now, before we begin, we need to understand one of the most important issues here. We need to understand that 1 over x, all right, the limit as x approaches infinity, 1 over x will be 0. And it's kind of hard to comprehend this at first. You're saying that x is getting bigger, sir, but the thing is going to go to 0. How is that possible? Well, let's look at it. Okay, right here at the bottom I have 1. So 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 5 is 0.2. 1 divided by 10 is 0.1. 1 divided by 100 is 0.01. 1 divided by 100,000 is 0.00001. Did you notice that as x on the bottom here is getting bigger and bigger and bigger and bigger and bigger, what am I noticing about the value? 1, 0.5, 0.2, 0.1, 0.01, 0.00001. Did you notice that as x gets bigger, the whole thing is getting smaller? So we are going to keep that in mind, that the limit as x approaches infinity of 1 over x to any power will be 0. That's going to be very, very critical. So let's go ahead and look at an example here. I have an example of a function of a problem here. So what I'm going to do is I have to keep the previous slide in mind. So what I'm going to do is I'm going to take the 2x cubed, the plus 5x, and I'm going to divide divided by 8x minus 4x cubed. What I'm going to do is I'm going to find the biggest x with the biggest power in the numerator and denominator. And what do I have here? I have a 3 here, I have a 1 here, I have a 3 here, and I have a 1 here. So what's the biggest value? I have 3. So then I'm going to divide everything by x cubed. Okay? Remember that in math we can do that as long as we do it to everybody. X cubed, x cubed. So what happens when I divide everything by x cubed? I'm going to end up with the limit as x approaches infinity of 2 plus, now here I have 1x and here I have 3x's. One of them cancels, so I'm going to be left with 2x's divided by 8 over x squared minus 4. Well, remember what we said. As x gets larger and larger and larger, this is going to go to 0. So that's going to go to 0. And this is going to go to 0. So what am I going to be left with? I'm going to be left with 2 plus 0 over 0 minus 4. So I'm going to be left with 2 over negative 4, and I'm left with negative 1/2. So my answer for this limit is going to be negative 1/2. All right, let's try another one. Okay. So in this problem, I find the power here. So the biggest power that I find is going to be that 5. So I'm going to take the 2x squared and I'm going to divide it by x to the 5th. I'm going to take the 7x and I'm going to divide it by x to the 5th. I'm going to take 8 divided by x to the 5th minus 4x to the 5th divided by x to the 5th. And in this scenario, when I reduce these problems, I'm going to end up with, let's see, I have 2 here and I have 5 here. That means that I'm going to be left with 2 over x cubed. Minus here, I'm going to have 1 here and 5 here, so I'm going to be left with 7 over x to the 4th. On the bottom, I'm going to have 8 over x to the 5th minus 4. And I have the limit as x approaches infinity. Okay? And this should have been the next. So now, what did we just finish saying? That the one thing that we have to remember, that any number over x here is going to go to 0. So that's going to go to 0. This is going to go to 0. This is going to go to 0. So I'm going to be left with 0 minus 0 over 0 minus 4. That's 0 over 4, which is 0. So my answer will be 0. All right, let's try one more example now. All right, in this case now, let's look at this problem and we're going to find out that the biggest power that we have is x to the 4th. So I'm going to divide everything by x to the 4th. Okay, so I'm going to have x to the 4th here plus 2x over x to the 4th over 3x cubed over x to the 4th minus 2x squared over x to the 4th. And in this scenario, all right, oops, this should have been an x here. In this scenario, this is going to reduce to 3 plus 2 over x cubed over 3 over x minus 2 over x squared, the limit as x approaches infinity. So when I get that, I'm going to end up with 3 plus 0 over 0 minus 0, which is going to be 3 over 0. And that, from the previous videos, we find out that 3 over 0, there's an asymptote there. So that means that my answer is going to be either infinity or what? Negative infinity. Now, how do I know which one's the correct one? So what you're going to do is you're going to think of, what am I substituting? Remember, what am I substituting into my problem? And in this case, I'm substituting an infinity. So you only look at the biggest power. So in this scenario, the biggest power is up here, and the biggest power on the bottom is here. So when I plug it in, I'm going to end up with a positive on top and a positive on the bottom, and that is going to give me positive infinity. Okay? Now, there's a shortcut to doing limits at infinity. We have Bobo, Bowtie, and Soskov. Now, what does Bobo stand for? Bobo stands for bigger on bottom. So bigger on bottom means that my answer will be 0. Bowtie means bigger on top, and my answer is going to be infinity or negative infinity, depending, once you plug it in, which one is the correct one. We don't know until you plug it in. And then finally, Soskov, which stands same over same, SOS, and it stands for coefficients. So basically, what you're going to do is you're going to find me the biggest power in the numerator, the biggest power in the denominator, and then determine if it's Bobo, Bowtie, or Soskov. So let's go back to the 3 that we have previously done here. So in example number 1, I look at the biggest power on top, which is a 3. I look at the biggest power on the bottom, which is a 3. Same over same, same over same. So that means that it's going to be Soskov, which are going to be the coefficients. So who's the coefficient? This is my coefficient. 2 over, and who's the coefficient here? Negative 4. 2 over negative 4 is going to be negative 1/2. And that is exactly what we got over here. So that one was Soskov. Now we look at this one. What about this one, Mr. Quintana? On this one, we look at the biggest power on top, which is a 2. The biggest power here on the bottom is going to be a 5. So it's bigger on bottom. So my answer is going to be, bigger on bottom is Bobo, right? Bigger on bottom, Bobo. So my answer will be 0. All right? Bigger on bottom is Bobo. And then finally on this one, the biggest power here is 4 and the biggest power here is 3. So it's bigger on top. So my answer is going to be infinity or negative infinity. So let's go ahead and try some more. Okay? Now remember what I said. Whenever they ask you for a horizontal asymptote, it's really going to be Soskov. Okay? To have a horizontal asymptote, it's going to be Soskov. So let's go ahead and look at some of these. All right? So right here, the biggest power here is a 1. The biggest power here is a 1. So my answer, the limit here, or a horizontal asymptote, would be located at y equals 2/5. On this one, my biggest power is a 1, and on the bottom, the biggest power is a 2. It's bigger on the bottom. So y equals 0 is a horizontal asymptote. Okay? Let's go ahead and look at the next one. We have a 3 here and a 3 here. So I have a horizontal asymptote at y equals 7/1. Here I have a 5 and I have a 6. It's bigger on bottom, so y equals 0. And then finally the last one, we have 7 here and we have 3 here. So this one is bigger on top, so my answer is going to be either infinity or negative infinity. Which one do I choose? Well, if I'm plugging in infinity, I'm going to get a positive on top and a positive on the bottom. So that means that I'm going to get positive infinity as my answer for both times. We look at another one. Right here is same over same. So my answer will be y equals 2 is going to be a horizontal asymptote, or the limit at infinity is going to be 2. This one is bigger on bottom. Here's a 1 and here's a 2. So it's bigger on bottom. So y equals 0 is a horizontal asymptote. Or you can say that the limit at infinity is 0. Same over same is going to be 9/2. So I have an asymptote at y equals 9/2. Or you can say that the limit at infinity is 9/2. Here's bigger on top. So my answer will be infinity because this guy is positive and this guy is positive. And on this one, as I plug in on this one, this is a great one because if you notice on this one, I have an 8 here and a 5 here. So this one here is going to tell me that it's going to be positive, while this one's going to be negative. So that's going to tell me that my answer is going to be negative infinity. And those are examples of Bobo, Bowtie, and Soskov, which are limits at infinity. Okay? And there's more here, but I'm not going to go into those. Okay?